Hello, dear engineers. Today in the series of DSA, we will be looking the algorithm for converting the infix notation into postfix notation. Here we are provided with a p, that is in infix notation, and we will be converting this p, which will be equivalent to the value, but it will be shown in postfix notation only. Okay, so this algorithm uses a stack, where we temporarily hold the elements, and in this algorithm we will be using stack to hold the operators and left parenthesis, only these two. First is operators and the second is left parenthesis, and the postfix expression q will be constructed from left to right using the operands of p. Okay, and operators. We will use the operators and operands of p. The operators are what? The plus, minus, multiplication, and operands are like the any integral value or algebraic value of p, and we will be constructing the resultant q using those elements. Okay, so it will be good if you study all these steps by your own for a while. Later I will explain. Okay, so very first step for conversion of an infix notation into postfix notation is that add a left parenthesis into the stack column. Okay, later we will see in an example that we are creating three columns of this all the symbols of p. The second column will be stack, the third column will be q. So the left parenthesis will be added to a stack. Here there will be no any left parenthesis provided in p, but you have to add it by yourself. Okay, and one more thing, the right parenthesis at the end of p, that is infix notation. Okay, so for given question you have to add p into p this, and for the stack add the left parenthesis. Okay, so start scanning from left to right and step 3 to step 6. The very first step of step 3 is that if an operand is encountered, okay, like an integer or algebraic value, then add it to q, the output string. Now if there is any left parenthesis like this, if this is encountered, then push it into stack. Okay, the second column. If the left parenthesis is encountered, put it into stack. If an operand is counted, put it into queue. Now this is very important. If it is an operator what? Like multiplication, addition, division. And for operator I would like to say this order of precedence. Okay, the most high order of precedence is dollar and power, and the second is division and multiplication, and the third order is plus and minus. Okay, so for an operator, repeatedly pop previously stored operator from stack. Okay, suppose there is an operator in stack, you have to pop it, you have to remove it from the top of stack. Suppose in stack column you have like this element, you have to pop first of all this into queue. But popping have some rule. What's if uh, which has the same precedence or higher precedence than the newly scanned operator. Okay, suppose you have taken a new symbol from infix notation, that is p, but the stack should have same precedence or higher precedence to pop it. Okay, we will look this thing more clearly in example, but suppose for a while here you are provided with division symbol. Okay, there is already a division symbol, and from infix notation, that is from p, you are getting a symbol of power. So what you will do, you will look that the previously stored in stack, this is stack column. Okay, if it has lower precedence, or sorry, if it has higher precedence or same precedence than the newly scanned operator, this is the newly scanned operator, then you have to pop it. But this is power symbol, and I have told you that power have higher precedence than division, so this will not be pop into a stack. Okay, this division will not pop into queue, and this power symbol will come just after this symbol here, like this. You will get to know this thing clearly in example. Okay, and add the new operator. This is the new operator, newly scanned operator, into the stack. Okay, and the very last step, the right parenthesis. If right parenthesis is encountered from infix notation, what you have to do? Repeatedly pop operator from stack. This is stack. You have to pop the operators from here into queue until a left parenthesis is encountered. You have to pop one by one from top, from this, then this, and remove left parenthesis from stack. There should be a left parenthesis and it will be removed, and you have not to add it anywhere. Okay, now we will look this thing from an example. Okay, so here we are with an example. It would be good if you solve this by your own first. Later I will explain. Okay, so here it is a infix notation. A plus left parenthesis b multiplication c minus left parenthesis d division e power f right parenthesis multiplication g right parenthesis multiplication and h. Now you have to put all the symbols a plus left parenthesis b multiplication one by one into the symbols and follow the steps of putting into stack and into the queue. Now what is the first most step for solving this question is that add a left parenthesis into a stack and and add a right parenthesis after this h. Okay, okay, now scan from left to right of all the symbols of p and follow those steps. Okay, so the first symbol is an operand, so what we will do, simply add it to q. Now the next symbol is plus, add it into a stack. The next symbol is left parenthesis, add it into a stack. No change in q for now. Why? Because there haven't been any operand for these two. Now again there is an operand. The stack will remain as it is, but you have to add these operand just after the q first element. Okay, now here it is an operator. Since there is no any operator previously, means after this left parenthesis, so there is no any case of comparison, you have to simply add it into stack. Now here it is c, add this into q. Now there is minus symbol. Okay, so now there will be comparison. I- uh, from the stack we will look that if the stack have the same precedence or higher precedence than the newly scanned operator, right? This is the newly scanned operator. Does it have higher precedence? Yes, it have higher precedence than the newly scanned operator. So what we will do is that we will pop this operator to queue and add the newly operator into a stack. Okay, now there is left parenthesis. For left parenthesis, simply add it to stack. Operate operand a b c multiplication d. Now division operator. Is there any operator previously to compare? No, simply add. Now operand a b c multiplication d e. Okay, now there is power symbol. The newly scanned operator. Okay, and this is the previously stored in stack. Does it have the higher precedence or same precedence than newly scanned? No, it have lower precedence. So what we will do is that simply add it into stack. No change in queue. For operator, we are not changing if putting pushing into stack. Okay, and in a stack there are only two things that is happening. First is For left parenthesis and operators, there will be no operands like an integer or algebraic in stack. Only left parenthesis and operators. Here it is operand, add this here. Right parenthesis, very interesting. You have to simply pop all this one by one and remove, omit this left parenthesis. Okay, add this. First write the previously q, d, e, f. Pop one by one. Why? Because there is right parenthesis. Okay, first done, second done. Now this remove. Okay, done. Now uh, this is again the case of comparison. Does the previously stored element has same precedence or higher precedence? No, it has the lower precedence. So what we will do, simply add it to stack. Now an operand. Okay, for operand we will be doing this thing, adding it into queue. Now right parenthesis is encountered. For this we will pop the previously stored stack operators into queue. Okay, the first one is popped, the second is minus popped, and the left parenthesis will be omitted. No left parenthesis here. Now the multiplication symbol. Does the previously stored operator in stack has same precedence or higher precedence? No. Then we will add this newly scanned operator into stack, and the queue will be as it is. Now it is an operand, add this into queue, and here it is right parenthesis, so we will pop these operators from stack and remove this left parenthesis. Okay, so a b c multiplication d e f power division z multiplication minus h multiplication and plus. So this is our final postfix conversion from infix. So if you have any doubt regarding this conversion, you can pin this to comments. I will try to reply as soon as I can. Okay, so this is the postfix notation. I hope you like the video, and please don't hesitate to ask any doubt. Thank you.